let's discuss some examples on power. And we already have mentioned that power is given as force times velocity times cosine of theta, where theta is the angle between force and velocity. You may be wondering why when force is in this direction, velocity is in that direction. Well, we can have a simple case in which a force is pulling this mass like that, but still this mass may be moving in this direction. Let's say this is the x direction, this is f, this is theta. So it's not always true that things are going to move or accelerate in the direction of force. Right here, because of the presence of gravity, the motion is along the x-axis, while force is not really only in the x direction. Anyway, so this is how the power is given, and let's consider some example. First example is that let's say you have a car and the maximum acceleration this car can give is 10 meters per second square. The mass of the car is 2000 kilograms, and the maximum velocity this car can reach is 40 meters per second. So what is the maximum power this car has? Like, what is the most amount of power this car's engine can put in the motion? That looks nothing like a car, but let's assume that's a car. Okay, so how should we calculate that? Well, a car is moving like this. Also, we know that we have been given a maximum. That means F maximum is going to be m times a maximum, and that gives us 2000 multiplied by 10, which is 20,000. Well, P maximum we know is going to be F maximum multiplied by V maximum, which is 40 multiplied by 20,000, and that gives us 8 multiplied by 10 to the power 5 watts. The units for power is watt, or watt is also actually joules per second, because we already know that power has the same unit as work over time, and work has units joule. And if you may recall that joule has units of force times distance, which means kilograms meters per second square times meters, which gives me kilograms meter square over second square. This whole thing is a watt. Okay, so that is one example. Let's take one more example. So what we have is a lift. Now this lift we have these two rails, and there's a lift that can go up and down on these two rails. That is the lift, let's say, and the mass of the lift is, let's say, 2000 kilograms, and the maximum velocity with which this lift can go up is 1 meters per second. So what is the maximum power this lift has? Okay, again we have to use the formula P equals FV cos theta. Well, theta is 0 in this case. You see movement and force are in the same direction. So this is the formula. Now what is F, by the way? What is the force that lift is applying to move this thing upward? Well, it's going with a constant velocity, so this lift has to overcome a force of gravity. So all the time this lift has to apply a force like this, such that it's overcoming the gravity. So this is the force it has to apply, and this is the velocity with which it's moving. So what is the power? Well, F is going to be mg multiplied by the velocity, which is 1, and that gives us 2000 times, let's say g is 10, times 1. So that gives us watts, right? We have assumed g to be 10. Okay, let's take one more example. Let's say we have a car, and this car, when moves, encounters air friction of let's say 0.3 v square. That means the air friction depends on the velocity of the car. If the car is moving faster, the air friction increases. Well, we know that air friction increases with velocity, and actually it depends on the square of velocity. Also, the maximum power this car can provide, let's say it's 150, or let's say it's a sports car, so it's 200 horsepower. People give different definitions to horsepower, but let's assume 1 horsepower equals 750 watts. Okay, so the question is, what is the maximum velocity this lift can achieve? Okay, so how to solve this? We know that P max is going to be F max multiplied by V max, which means when the lift is putting the maximum power, it is also putting the maximum force. Well, no, let's not put F max, just put F, the force. We really don't know this putting the maximum force or not. We certainly know the car is putting the maximum power when it's trying to move the vehicle with the maximum velocity, right? So this is achieved with that. But what is F? What is F? Well, when the car is moving with a V max, it does not have any acceleration acting on it, similar to the previous case. But there's a wind resistance which is 0.3 v square, and what the car is doing is putting a power P. So the force it's trying to put is same as 0.3 v square, or let's say instead of P, let's put a F. So the force car is putting at this point is same as 0.3 v square, but they cancel each other, such that they cancel each other, and the car is moving at the maximum speed. You really can't go above this speed, because that is the force, that is the best force your car can provide. So P max should be 0.3 v square dot, well, actually it's actually V max here because it's moving at the maximum velocity, times V max, right? Just use this formula, and that gives us 0.3 V max cube equals 750 multiplied by 200, right? That is the power the car has, and that gives us V max equals 2500 multiplied by 200, which is same as 50,000, and this is cube, So V max turns out to be, if you do a small calculation, 0.5 to the power 3 multiplied by 100 meters per second. That's a lot of speed. But probably we did not take a realistic value of air friction. This looks realistic. Cars can have power of 200 HP, but this may not be very realistic. But we know for sure that the air resistance depends on V squared. But this coefficient is called the drag coefficient, may not be the realistic value. But anyway, it's not really off the charts. So this is how we solve problems on power. Just try to identify the force, what force is it the system is putting. In this case, the force put by the lift is nothing but the force which is required to encounter gravity. In this case, force put by the car is nothing but the force which need to be put to encounter air friction.